So this is just going to be a quick video going over the polynomials redemption, just going through each question and sort of how you do it. Firstly, excuse the horrible handwriting, I'm still learning how to write on my iPad. It gets better, I promise. So our first question here, which of the following is not a polynomial? So firstly, a polynomial, this is a whole positive power of x. So it's just identifying all of these and which one doesn't match this criteria. So this is A, and because when x is on the bottom, that's a negative power of x. Question 2. Expression for the discriminant is mx squared plus 3mx minus 4. So the trick here is just locating your coefficients a, b, and c, and remembering your formula for the discriminant. Well, not even remembering, it should be in your book. So our discriminant formula is b squared minus 4ac, and it's just substituting in those values and simplifying. Question 3 here, when x cubed plus 5x squared minus 4x plus 2 is divided by x plus 4, the quotient and remainder respectively are. Remember, remainder, you can use your remainder theorem. So this is just what I've done here, and this is just substituting in negative 4, and this gives us a value of positive 34. And then you can do this quite simply on your CAS to find the quotient, so you can actually find the remainder very similar way. So I've just put the steps here, but you get poly quotient come up, and you just put your fx value and then what you're dividing by, and it will tell you this. You can also do this by long division, but that takes time. Question 4. The graph of 2 and then x minus 5 plus 3 has a point of inflection. Remember, this cubic, this is in inflection form. So the values that I've highlighted here, these tell you how far up and, well, firstly, left or right, then up or down, this has moved. So remember, whatever's next to the x, and happening there, that tells us our left to right, and that goes in the opposite direction. So this goes positive 5, so to the right 5, and then our constant at the end, that tells us it goes up 3. So this means the inflection point has moved to the 5 right, up 3, so it's 5, 3. So the domain of the function on the right is, and I always suggest if you're still having troubles with domain and range, you can draw it just like I have here. Domain, this is the x values of the graph that this goes over. So this here, our x values, we look at where it starts, which is negative 2, and it stops at that point, so that's including that point because it's coloured in, and then it goes all the way to 6. And just looking at the x values, don't worry about the y values, don't worry about this point here because it starts here and that's where the end is there. So domain's the x values, and doing the range, they're the y values, okay? So you would actually look at this y value down here and the y value at the top, okay? Because that's where it goes over. So the domain, this goes from negative 2 to 6. Question 6, which of the following relations are functions? Just remember, when you're doing and finding functions, you can always do a vertical line test. I've just put a screenshot of what all these functions look like on CAS. Okay, I just went to the relation. You can do that by deleting on your CAS. When you get into the graph section, it comes up with the option of relation, and just type them all in as they're written here. And you can just do a vertical line test by eye, okay? And hopefully we know, and we've gone over, you can identify two straight away. Firstly, this is a quadratic. We should all know these are functions now, and this is a linear function as well. So they are there. It's just about testing these other ones and doing the vertical line test. So our answer is just 1 and 2. The midpoint of the line segment, question 7. So this is just using your midpoint equation, as stated here. And then it's just about subbing in the values, just like normal. Just because there's a variable there doesn't mean that you do it any differently, okay? Just sub these in and then see which answer it is. And hopefully, once you've done all this, you've got d plus 1 over 2 and then negative 3 over 2. Oh, sorry about the handwriting here. Alright, so we've got this function and x squared minus 5x plus 6. Find the coordinates of the turning point using completing the square method. Just remember, you can always put it in turning point form, that is quadratics, when it's the highest power is squared, into turning point form. by completing the square. And that's why we do it. It's just so it can be essentially used to find this easy way of graphing them. So this is going over our completing the square method. You get the b constant, which is -5 over 2 squared. -5 over 2 squared. Just remember, the b over 2 value, that's going to be the variable in your square, as you can see down here. And it will always be that, if it's negative or positive as well. So this one's -5 on 2, so it's x minus 5 on 2 squared. So we just need to do the other part of completing the square, so you need to figure this out. You plus 1 to this side of the equation, then you put your then you keep your constants past that. So then you complete the square on this first half here, well, first 3 terms. Complete the square there, and that will always be the b over 2 value. And you can just write it like you have there. Okay, if that's the simplest form. If it was 6 over 2, you would obviously write it as 3. But then we just need to do plus 6 minus 25 on top of 4. Okay? You can do that in your calculator. You can actually just do it by hand as well. Make it all over 4 and minus them together. Okay? And this becomes minus a quarter. Alright, there's actually a completing the square function on your CAS as well, so you might want to have a play around or look up a video on that as well. But whenever you're doing this, when it's saying using the completing the square method, that means that we actually want to see the method, so how you actually do it there. Okay, and that's the mark distribution. One for b over 2 squared variable, another mark for adding and subtracting it to equation, and another mark for writing out the equation there. Sketch the graph of y is equal to x squared minus 5x plus 6 on the axis provided. So label the axial intercept, so that means x and y intercepts, and turning points with their coordinates. So I've just done the working out for the y-intercept and the x-intercept here, and you should hopefully be very confident with this. Y-intercept, x is equal to 0. If you're not feeling confident by doing it by hand, just have a go on CAS, but make sure it is very important to be able to do this by hand. So just that's rearranging equations, those types of things. And then our x-intercept, y is equal to 0, and we solve for x here. Okay? Just remember, when you're getting rid of a squared, it can be a plus or minus square root 1 on 4. And the square root of 1 is 1, and the square root of 4 is 2, so that's how come that turns to plus or minus a half there. Okay, so there are our x and y intercepts. Make sure you graph them here. Sorry for my bad arrows. And our turning point, that's up in our turning point form that we figured out in the question before. So we should already know that, and it's just about graphing this accurately. Try and get the axial intercepts in the right spots. Okay, sorry, I'm still not the best at drawing on my iPad, so excuse that. Oops, sorry. So just make sure you get the axial intercepts, and it looks somewhat like a parabola, and these arrows mean that these continue indefinitely up and continue definitely up and out. Okay, and that helps for our next question, domain and range of this same function. So domain, this is the x values. So we look at the x values. This keeps on going out forever and ever and ever. So technically this will keep going out way past -10 forever and ever, and it will keep going out past 5 forever and ever here. Okay, so our domain is actually -infinity to infinity, and that's worth one of the marks there. And our range, so our range is the y value. So look at your function here, our y value, it stops here. So range, just look at up and down. Look, this keeps going forever up, so that will be positive infinity. We know one of the values there. That will keep on going up forever and ever. So we go down, we stop here, and the function, it doesn't go any lower than this point here. So we just need to look at the y value of our turning point here, which is -1/4. Okay, and it touches that point, so that means that it's a square bracket. And just remember with your infinity, it's technically, because infinity isn't an actual number, it's an open bracket. So that's from -1/4 to infinity. Alright, and there's 1 mark each for that. Question 2. This one is using our factor theorem, so it's just knowing the theorem and how to apply it. Alright, just because that there's unknowns in it doesn't mean that you apply it any differently. Okay, the theory is all the same, so just make sure you're feeling confident with that. if you know your theory, you can do any question, just apply your theory, and then you might just need to work out a couple of rearrangements or different steps here. So using the factor theorem, write down two equations in terms of A and B. And I gave you a little note here just to remind you of the factor theorem. Okay, so just remember you're subbing in the opposite variable, so this is x minus 3, so if you sub in 3, this will equal 0 as it's a factor. Okay, because it's told us in the question that these are two of its factors. Alright, write down two equations in terms of A and B. So 0 is just equal to all of this when 3 subbed in for x. Okay, and this simplifies down to 0 is equal to 27a minus 12 plus b, or you can put 12 is equal to 27a plus b. Doesn't matter as long as it's some form of that equation. Okay, second one here, we're subbing in negative 1 because this is the x plus 1 factor here, and that's equal to 0. So you're just subbing in positive 1 and simplifying it down. Okay, and that's the other mark there. Alright, my mistake here. When I was doing this, I must have forgot to change this when I changed the numbers. So, doesn't equal them, but here, this is just simultaneous equations. It doesn't say you have to do it by hand, you can do this on your CAS, okay, as well. So just make sure you look up solving simultaneous equations on CAS. It can save a lot of time, and it can be good for your more difficult ones as well. So I've just done this by hand. So we have equation 1 or 2, and I've rearranged it just to get the variable, or not the variable, the constant by itself here. Okay, so I've plus 12 to this equation to make it 12 is equal to 27a plus b, and then I've, sorry about that, I've plus 4 to this equation here, our second one, to make it 4 is equal to a plus b. Then I've just minus the equations together because we've both got a variable of b. It's the same. If I minus the equations 1 from 2, it will allow us to eliminate b and then find a solution for a. Okay, and then simplifying it down, a is equal to 8 over 26, which is 4 on 13. And 4 is equal to 4 on 13 plus b. Okay, and then it's just about breaking that down as well. Alright, you need to be confident with using fractions. They're just like numbers, so you're adding and subtracting fractions as well, but you do have a CAS or a calculator there to help with those more difficult ones. Alright, this is probably the hardest question here. So another polynomial qx is equal to x cubed minus 7x minus 6, and also has a factor x plus 1 and x minus 3 as two of its factors. So here this combines a couple of different things. First is using long division. So we divide our x cubed, and just remember when you're using long division, write in the variable that's missing, so our x squared, but just put it as a coefficient of 0. Okay, just so everything lines up and it's a lot easier to do. Minus 7x minus 6. So just remember first, what you're doing is doing x cubed divided by x, which is equal to x squared, and that's our term up the top here. Okay, then we multiply whatever answer we got there by everything out the front here. So it's x squared times x plus 1. Alright, this becomes x cubed plus x squared. And then we take that away from these two up here. Okay? So this becomes x cubed plus x squared, and taking it away, so x cubed minus x cubed, this one should always eliminate. Your front one should always eliminate. And then we've got 0x squared minus x squared, so that's minus x squared. Then we repeat our process. So we do minus x squared divided by x. Okay, that gives us minus x. Then we multiply minus x by everything here, so minus x times x plus 1, and that gives us minus x squared minus x. Just remember to take away everything there, so it will switch the signs of these. So it becomes minus x squared plus x squared, that eliminates. Correct, we've done it right. Okay? Sorry, in the last one, just remember to drop down your variable here. And then we've got minus negative x from negative 7x, and that's minus x here. So that's minus 6x. And silly me, I've rushed here and forgot to drop the negative 6. So this negative 6 should be here. Okay. obviously got to let me write. There we go. So that should be 6. Alright. And that's dropped down there from the top here. And then we've got minus and just dividing all that out, and it's the same process. Okay, so it's just remembering essentially 3 steps of long division, and it's just following them through. Okay, it may look long, but it's only 3 steps. Then we got our answer of x squared minus x minus 6. Okay, and this is our factorizer, and we're using the sum and product method here. Okay, and this is very easy when it's monic, so that means that there's no coefficient in front of our x squared term. So we just need to find 2 numbers that add to equal our b term, which is -1, because negative x is -1x, okay, and multiply to make our last variable, which is -6, not last variable, the constant here. So these 2 numbers, hopefully you can see them or find them pretty quickly. It's 2 and -3. Also, you can just use factorize on your CAS, okay? You can write factorize this here, okay, and that will give you the answer of x plus 2, x minus 3, alright? So now it's just about combining all these. So x cubed minus 7x minus 6, that's x plus 1 times our answer here. Alright, and then we factorized our answer here, okay, to x plus 2, x minus 3. So it's x plus 1 times x plus 2 times x minus 3. So the other factor here is x plus 2, which is shown here because that's the one that isn't up the top. Okay, so just remember, it is a bit of a process, but long division, it's essentially remembering 3 steps and repeating the process, 3 or 4 steps. Okay, and then factorizing, it's about being confident with factorizing. It's a very important skill. Okay, so just make sure you are feeling confident with that. So there was a mark here for doing the long division, a mark for doing the factorizing, and a mark for getting the last right answer there. Okay. This question 3, state if it's a function or not. All this is vertical line test. If it goes through more than once, it's not a function. Okay. Anywhere where the graph is, if it goes through more than once, it's not a function. Okay. So that's all I've done there. So you can see here, this one goes through twice here, not a function. This one goes through twice at this spot, not a function. These ones only go through once, they're functions. Alright, now here's our worded question. These are very important to be able to break down what to do. Okay? So, a carpenter wants to construct a window with a glass portion surrounded by a wood trim on all sides. The height of the glass portion of the window is 1.5 times the width of the glass portion of the window. So what I've done here is just write down this bit of information algebraically. So the height, if we've got 2x here as our width, okay? So our height is 1.5, so it's just 1.5 times 2x. So 1.5 times 2 is 3, okay? So that's 3x. And the width of the wood trim is 2.5 centimeters surrounding the glass portion of the window. So that's just 2.5 centimeters there, up the top, there, and down the bottom. Alright? So, write down the expression in height of the window. So, this is the whole window. It didn't say the glass portion, but still, if you have done this, just give yourself the marks for that. It's probably should have been a bit more explicit in the question saying the whole window or something like that. So our height, that's 3x, what we worked out, plus the 2.5 on each side. Okay, so that's plus 5. Okay, our width, this is 2x, and this is plus the 2.5 on each side, so plus 5. Okay, so that's 1 mark each for that. Write down an expression for the area of the whole window. So the area, that will be just area is equal to length times width. Okay, so it's multiplying it all together. Alright, so multiplying this, and it's just using your expansion of brackets. Okay, so that's all you do there. And then C, write down the expression for the area of the glass portion. So this is just working out the area of the wood trim. So we've already worked out the area, the total area in this question here. Alright, we just need to minus the glass area. in the glass area, we've got variables for that. We've got 2x and 3x. So that's 2x times 3x, which is equal to 6x squared. So there's just one mark for stating this, okay? So it's 6x squared plus 25x plus 25 minus our glass area of 6x squared, which breaks it down to 25x plus 25. And that's it for that. Just make sure if you do make just a little mistake, it's not the end of the world. Just make sure you're reading the whole question and actually feeling comfortable with expressing this information. Hopefully this has helped for those that might have been struggling, and good luck.